So इसका start कर लेते हैं कि we can let's see electrolysis. ठीक है. First thing, it's the decomposition of decomposition of a substance by passing of an electrolyte specifically. Not all substances they decompose. So decomposition of an electrolyte by passing. By passing current or by passing electricity. That's what electrolysis is. You pass current. Decomposition is that whatever the substance is, that substance is known as an electrolyte that decomposes or breaks down into smaller compounds or elements. And who are these electrolytes? You can't do it like if I have a copper wire, it won't electrolyze. It will pass current, but nothing will happen to it because it won't break down, right? If you pass current through it. But certain things will break down. I mean, we break down when current passes through us. We are an electrolyte, or we contain electrolytes. So we break down. I mean, our molecules, they break apart when electricity is passed through them. So electrolytes are substances that have free moving ions in them. So they've got free moving ions, not delocalized electrons, because anything that has delocalized electrons will only conduct electricity. That's it. It won't break down. So only free moving ions. And who has free moving ions? Free moving ions are with they're with acids, bases, and as they are acids, bases, and salts. And when do they have free moving ions? Whether they are aqueous or molten. So in aqueous state or molten state. ठीक है, is that clear? Yeah, for molten state. Solid state kind of like NaCl, it won't have free moving ions. They won't be moving around. So remember, I'll give you. I'll also write or talk about metals. So when you talk about, just a second, when you talk about metals, so the thing with metals is that they only have free moving electrons. Or delocalized electrons. The metallic structure is like this. It's a bunch of positive ions in a sea of free moving electrons. So electricity is the movement of charges. So you got a bunch of positive ions, and there are lots of electrons that are delocalized, that are just moving around, filling up the gaps between the lattice, between the metal lines. So when electricity flows through a metal, what happens is that electrons are flowing or charges are moving around, right? So when electricity flows through a metal, electrons come from one side and electrons go out the other side. That's it. The structure does not change at all. Is that clear?
Yes, sir.
So in metals, no decomposition. No decomposition products are produced. And electrons get replaced constantly. Because that's what electricity is. It's the movement of charges. But when you do the same thing to an electrolyte, acid, base, and salt, or anything that's got free moving ions, electrolysis will happen. And let's list down the acids, bases, and salts first. So it's basically any typical ionic compound, or a compound that would decompose or will react with water or dissociate in aqueous signs. Like some of these are not ionic compounds, like acids are not ionic. HCl is a covalent molecule. But when you mix it with water, it turns into H+1 and Cl-1 ions. So that's HCl, that's hydrochloric acid. So we're gonna list down all the acids. You got sulfuric acid. Sulfuric acid is made up of H+1 and SO4 minus 2 ions. It's H2SO4. But when it dissolves in water, it breaks down into H+1 and SO4 minus 2 ions. I've got phosphoric acid as well. So phosphoric acid is H+1 with PO4 -3, right? And then I've got nitric acid, that's H+1 with NO3 and -1. I've got carbonic acid. I've got different organic acids as well. We're not going to discuss those right now. Carbonic is one of them. That's kind of a weak acid. What other acids? I've got sulfurous acid, which is H+1 with SO3. -2, that's H2SO3. I've got nitrous acid, that's H+1 with nitrite ions, and that's NO2 -1. I've got phosphorus acid, that's H+1 with PO3 -3, right? So anyway, so let's have a look. I'm just going to write down the names quickly. This one is sulfuric, and I've got phosphoric, and this one is nitric, and we've got carbonic and sulfurous. You can make sure you know the names and formulas. This one is nitrous, and this one is phosphorus. So anyways, you need to know the names of all these acids, and you need to know what ions they're made up of. What are bases? Which compounds are bases?
They dissociate OH minus ions.
Okay, so they bases are compounds that are. We're not going to go into details about what bases really are. They're basically compounds that are oxides, or they've got O- ions, or they've got OH -1 ions, or the carbonates are also bases. So carbonate ions. So any carbonate, any metal oxide. So you got metal oxides, metal hydroxides, metal carbonates. So metal carbonates and metal hydroxides. Okay, so these are all basic because they've got ions as well. And the last one, salts are basically ionic compounds. Any two ions, as long as they're not an oxide or a hydroxide. So salts are the product of basically they're typical ionic compounds, neutral ionic compounds. Now you get A+1 Cl -1. So acids, bases, and salts, right? Because they've got ions, and they've got to be free moving ions. So it's either aqueous or molten state. Remember, acids, pretty much they can't really be molten state because most of these acids in their original state, they are. These acids, we're talking about them in aqueous state. In aqueous state, they break down into ions because otherwise these are covalent molecules. Then they don't have charges. The only thing is that when HCl mixes with water, this is what HCl looks like. It's a covalent molecule. It's an H with a Cl, right? And they end up sharing electrons, right? You got a Cl with 7 electrons in its outer shell, and you've got an H which has 1 electron, and Cl needs 1 electron, so the H comes in, starts sharing electrons, and that's a covalent molecule. It doesn't really have a charge, but what happens is that when it mixes with water, the H leaves its electron, and the H+1 dissociates, it breaks away, and Cl gets its electrons as well. So the Cl becomes -1. So that is what dissociation happens. When you stir it in water and you vigorously stir it, the HCl molecule, it breaks apart, it dissociates. The H loses its electron to Cl, it becomes -1, this becomes +1. But that only happens when it dissolves in water. Is that clear as well?
Yes, sir.
So remember, these acids are covalent molecules, but when you mix them in water, they actually turn into ions. Otherwise, they're not really ions. So they've got to be aqueous or molten. So how do you know whether something is aqueous? Do you know what the solubility table is?
Yes, sir.
Okay, so you must remember the solubility of, because something, if it does not dissolve, it won't have free moving ions. So what's the solubility table? I'm just going to copy the solubility table from so where's the think it's over here. So the data sheet, acid, base, and salts only, right? So I'm just going to copy the solubility table. You must know which compounds are soluble, which ones are not soluble, because if something is not soluble, no electricity can be conducted. So hold on a second. So this one. Here on the left side, you got the solubility table. So I'm just going to copy this one, starting with the alkenes as well. So these are the compounds that are these. So these are the compounds that are soluble. Group 1 are all soluble. NH4+1 compounds are all soluble. Sulfates are all soluble except for lead sulfate, barium sulfate, calcium sulfate. Carbonate phosphate salts are all insoluble except for group 1 NH4+1. And then you have chlorides, which are mostly soluble except for silver and lead. So remember this table. I've just copied this table over here. So first thing, I'm just going to mention. I'm going to do the first electrolysis, and before that, I'll just do a few questions. Can I do electrolysis of calcium carbonate aqueous?
Yes.
Is it soluble or not?
No, it's insoluble.
It's insoluble. So this one is not soluble. So at least in aqueous state, no electrolysis. And there's another problem that you can't even melt it because it will decompose.
Okay, sir.
So this one is not soluble. What about K2SO4? Can I do electrolysis of K2SO4 in aqueous state?
Yes.
Because K is group 1, so it is soluble. So electrolysis will happen because it will have free moving ions because it's soluble. So remember which compounds, if something is not soluble, no electrolysis. Second thing, gain of electrons. What do you call a gain of electrons? I mean, what word is used to describe gain of electrons? Because that is, do you know what reduction is?
G, sir.
Okay. And what's the loss of electrons?
Oxidation.
Okay, that one is, so that one is oxidation. So you got reduction and you got oxidation. Now the other thing is that so gain of electrons, loss of electrons, right? So then the next thing is let's start with molten electrolysis. So electrolysis of molten electrolytes. This is the simple one. That's the first one. So in molten electrolytes, the ions can freely move around. And let's start with NaCl. So in electrolysis, you've got 2 electrodes, and so here's the first one, and that's your second one. Let's place them together, and there's going to be a beaker in which the electrolyte will be present, right? So that's my beaker, and there's going to be a wire that will be connecting the 2 electrodes together, and they'll be connected to a battery. So that's my battery. Which one is the cathode and which one is the anode? What is this one? You know what this is?
No, sir, I don't.
Okay, so basically, you've seen electrodes, right? You've seen a UPS. Have you seen a battery, like a car battery or UPS battery, right?
Yes, sir.
So it's got these terminals, and you know which one is the negative, which one is the positive terminal.
So the positive one is the longer one.
Okay, so the bigger one is the positive one, and this one is the negative one. What does it mean that it's the negative one? What does that mean? Does it produce electrons? Does it send electrons, or does it accept electrons?
It sends electrons.
Okay, so the negative terminal is negative because it's got a lot of electrons on it, right? So it's got a very negative potential. So it's going to send those electrons. I mean, whoever comes into contact with the negative one, the reason it's negative is because it's got a lot of electrons. So it's going to send these electrons to whoever is over here. We don't know who's present over here at the moment, but whoever is standing over here will gain those electrons because there's a lot of electrons. And the positive one is electron deficient. So it's going to accept electrons. If it sees an electron, it's going to attract that electron, it's going to grab it, right? So is that clear? That's how electrons move from the negative to the positive, right? Is the circuit at the moment complete?
No.
It's not complete because the electrons can't really move from this point to this point, right? So I said these electrodes, these terminals are made from graphite. So these are graphite electrodes. So we're dealing with graphite electrodes. Graphite is carbon. It's very unreactive. I mean, it's considered an inert electrode. So this one over here is an inert electrode. Now, what will happen is graphite. The only purpose of graphite is to act as a point, as a terminal. That's it. So it's an inert electrode. Now, what if you've got molten NaCl? Now, NaCl is your typical ionic compound. NaCl looks like it looks like this. It's NaCl, ionic lattice. This is so it's a bunch of positive and negative ions. Just a second. So it's a typical. What's all to see? Let's go with this one. Look at this one. So it's a bunch of positive and negative ions all sticking together, right? That's what NaCl is. But once you melt it, that means the particles are energetic. They're no longer sticking together, right? So that means in molten form, the Na+1 and the Cl-1, they would all be roaming around. There's going to be Na+1 because they would be very energetic, right? NaCl has a high melting point. So the Na+1s and the Cl-1s, they're all sliding past each other, just like water. So in liquid state, molten state, they're all moving around. Is that clear?
Yes, sir.
Okay, so they're all sliding past each other now. It's in liquid state. This thing has melted. Now you've got a negative terminal. This one is the negative terminal. So the negative terminal is known as the cathode. And you've got on the other side, you've got a positive terminal that's known as the anode. You got cathodes and you got anodes. The names given to these terminals. Which ion will the negative one attract? And which ion will the negative one attract?
The cathode will attract positive ions.
Okay, they're going to attract the positive ions, and the negative ions will get attracted to the anode, right?
Yes, sir.
So what will eventually happen is that all the positive ions and all the negative ions, they will start splitting up. Previously, they were all sort of mixed together. They were all locked in place in a crystalline lattice. But now in molten state, and in the presence of these cathodes and anodes, the anode is attracting all the negative ions. And let's pick this up, put it over here. Pick this one, put it over here. So anyways, you got all your positive ions in one place, you got your negative ions in the other place. So basically decomposition has started. And so positive ions, I mean, the rule is positive ions are attracted to cathode, which is the reason why they're known as cations.
जी sir.
और दूसरी side पे the other side you got negative ions attracted to anode, which is the reason why they're called anions. Okay, so you got two sides. What will happen to Na+1 now? Like Na+1 is over here. It's what will the battery give it? What will the battery provide the Na+1?
With electrons.
It will provide it with electrons. So this Na+1 over here will end up gaining electrons, and it needs one electron, right? So it's going to gain one electron and it will form Na. Is that clear?
Yes sir.
So molten sodium, instead of sodium ions, you now have sodium. Is this reduction or oxidation?
This is reduction.
So this is reduction. At cathode, it's always reduction that happens. Reduction of, in this case, it's reduction of sodium ions. And then you have on the other side, you got your negative anode. So what will happen to the Cl minus ones over there?
They will give out one of.
Because the battery is going to take away electrons. The positive terminal will pull one electron out of Cl minus one. So it will release an electron. It will give so what will be the charge on the Cl now once it loses the electron?
It'll just be Cl.
It will just be Cl and it will lose one electron. Now here's a problem over here. That is that Cl, is Cl a monatomic or a diatomic molecule? I mean, which form does it take? So remember, it's diatomic. So Cl is diatomic. So instead, this is not what's going to happen. I mean, the equation would be very similar, except that there's going to be two Cl ions. And they would together lose how many electrons? They're going to lose 2 electrons. And two Cl atoms would be produced. And those two Cl atoms would join together to form a diatomic Cl2 molecule. Is that clear?
Yes, sir.
Remember, it's the same exact equation, nothing different, except that you just made it diatomic. Instead of one Cl ion, you got two Cl ions. If instead of one Cl atom, you got two Cl atoms that join together to form Cl2. And instead of one electron losing, they're losing 2 electrons together. So remember, which elements are diatomic? It's hydrogen, oxygen, nitrogen is diatomic, and the entire group 17 are all diatomic. So remember this fact, which elements are diatomic, because when they turn into atoms, and is this oxidation or reduction?
It's oxidation.
Okay, this one is going to be oxidation of Clides. So it's going to be oxidation of Clides, and so you've got reduction, you've got oxidation, and so that's pretty much it. That's what electrolysis is for a molten compound. You got one ion going to this side, which is usually the positive ion. You got the negative ion going to the other side, and the positive ions gaining electrons, the negative ions getting oxidized, losing electrons, and you can make an overall equation as well. So two different products are getting produced, and you can make an overall equation by adding the two equations up. So I'm going to pick this equation, put it here. Okay, that's one of my equations, and the other one, which is the Cl minus 1. And I'm just going to put the arrows together. I'm just going to add them up. Now, before adding them up, I'm going to make sure the number of electrons gained and lost are equal. So I'm going to multiply the whole equation by 2, right? The electrons gained and lost, they got to be equal. Is that clear? Like if this gains 1 electron, the other one should lose 1 electron. So they got to be equal. As anyway, so I'm just going to add up the reactants and the product. So if I do that, it's going to be 2 sodium ions on the left side, and it's got 2 Cl ions on the left side. On my product side, I got 2 sodiums, and I got Cl2. So that's my overall equation. for this reaction, and that's about it. So I've got these ones. What I'll do is I'm going to do another example. Let's say, and this one, quick question, Dani, is this clear? I'll just do one more example. Clear?
Sir, so when we add the equations together, do we just disregard the electrons?
Do we?
Do we disregard the electrons?
Because they get cancelled out like a math equation. Like on the left side, I've got 2 electrons, right? On the right side, I got 2 electrons as well, right?
Oh, yes, sir. Okay.
So it's basically the electrons are not doing anything. It's just one of them lost electrons, the other one gained electrons. So in the overall equation, they're not there because, I mean, they got cancelled out. Okay?
Yes, sir.
I mean, this is still left. Na is left, Cl2 is left, but the electrons are gone. This gain electron, this lost electron, that's it. So they're gone.
Yes, sir.
So overall equation, mein na, just make sure you make sure that electrons gained and lost are equal, and remember, this will only happen if you have aqueous or molten ions. I mean, we're doing molten, not in solid state. So I'm just going to do one more example. I'm going to take the example of, let's take the same diagram, and I'm just going to pick MgO now. Okay, so MgO is a, I mean, it's very hard to melt MgO. So I'm going to pick MgO now. The rest kind of, this is the anode, that is, so this one is the cathode, right? So in the solution, it's going to be, things are going to be different. I'm going to take another substance. I'm going to take MgO. अच्छा, वैसे directly बता दो, which ions will get attracted to the negative cathode?
Mg2 plus.
So the negative cathode will attract all the positive ions, and the positive ion over here would be Mg2 plus. So all the Mg2 plus, they gather on the cathode, and who's going to get attracted to the anode? That's going to be
O2 minus.
I think it's going to be O, and minus 2 is the charge. So all of them, they get attracted to the anode. Achha, so what will be the equation over here? What will happen to Mg?
It'll gain 2 electrons.
Okay, so Mg is plus 2. It needs 2 electrons, and the battery is providing it with electrons. So it's going to gain those 2 electrons, right? And it will turn into Mg. So Mg metal would be produced at the cathode. That's the equation. That's the reaction over here. And what's going to happen at the other side? What's the equation?
Oxygen's going to lose electrons, but since it's diatomic, we're just going to multiply it by 2.
Okay, so oxygen is going to lose 2 electrons, right?
Yes, sir.
So I'm going to multiply it by 2 at the end. So oxygen is going to lose 2 electrons. It will become an oxygen atom, and it will lose 2 electrons. But again, it's diatomic. So it's going to be 2 oxide ions. And 2 oxygen atoms would be produced, and they would become O2. And the number of electrons produced would be 4 then, right? Is that clear? So is this equation clear?
Yes, sir, it's clear.
And you can then go on to make an overall equation, which is that you just put them together and you just add them up. So we're going to do just that. So that's one equation. That's the other equation. Who do I multiply with? Like,
Multiply the Mg equation by 2.
okay, so I'm going to multiply the Mg equation by 2. And so we've done that. And the overall equation would be 2Mg plus 2. And the bottom, it's 2O minus 2. And the products at different electrodes would be, on one electrode, it's going to be Mg that's going to be produced, and the other one, it's going to be 2 Mg that's going to be produced, and the other one, that's going to be O2, right?
Yes, sir.
So that's about it. So you calm questions, Karla. If you, I'm going to give you some questions. Number 1, potassium oxide, right? Do everything, make the 2 equations, then add up, make the diagram as well, and to show that exactly the way I'm showing it or doing it. Anyway, second question is aluminum oxide, right? I said, remember it. Remember, the formula doesn't really matter. What matters is what ions do they have, right? Like, I don't care if it's K2O. What ions does will the liquid state have? It's going to have K+1 and it's going to have O-2, right? Al2O3. Don't forget the formula. It's got aluminium +3 ions and it's got O-2 ions, right? So ignore the formula. Like, forget the crisscross. You're just interested in what ions does the compound have, right? The third one, that's magnesium nitride. Do that one. And all of them are molten and inert electrodes are used. ठीक है, so ठीक है, send me the answers to these by tomorrow. 3 of them along with the diagram, right? Exactly the same way. I'm going to share the board link as well for you with you. Just once.
Okay, sir.
So ये जो ना, I'm sharing it over here, ठीक है, in the chat. चल ठीक है आमना, ठीक है, अल्लाह हाफिज़.
Allah Hafiz, sir.